Hi, 8th grade. We are going to go over 7.5. You're going to need this graphic organizer, and we're going to talk about the distance formula. Now, this section is actually called using the Pythagorean Theorem, but I really want to focus more on the distance formula that they teach you as well. So I do want your book open to page 320. And I'm just going to go through and read the key ideas, and then we will go ahead and get started on our distance formula notes. Don't forget, you can always pause the video if I go too fast. Rewatch it if you need to. Now, the first thing I want you to talk about is using the Pythagorean theorem to prove if something is a right triangle. You guys know that the Pythagorean theorem only works for right triangles. Like, it has to be a right triangle for it to work, right? So if that's the case, can't I prove then if things are right triangles? So for example, A and B, I'm going to go ahead and cover them up. I know that you guys can see them too, but it's not that I'm trying to hide the answers, just, so we can do some work. It says, tell whether the triangle is a right triangle or not. Well, to be able to prove it, it should work for the Pythagorean theorem then. The Pythagorean theorem is a squared plus b squared equals c squared. It doesn't matter which leg is A or B, I'll just pick one. I got 9, and grab a skinnier marker there. 9 squared plus 40 squared should equal 41 squared, if this is true, right? Okay, so I'm going to grab my calculator. I know that 9 squared is 81. I know that 40 squared would be 40 times 40, which would be 16 for the 4s, and then add 2 zeros. And now 41 squared, I am going to use my calculator on that. 41 squared is 1,681. Okay, now what is 1,600 plus 81? 1,681 equals 1,681. It works. So that means this is a right triangle. Now B, you can kind of already tell just by looking at it that looks greater than 90 degrees. But just to prove it, I can use my formula a squared plus b squared equals c squared. It doesn't matter who's A and who's B, so I'm just going to say 18 squared plus 12 squared, and then that'll equal the hypotenuse squared. All right, 18 squared is 324. 12 squared is 144. I have that one memorized, which you should too. 24 squared is 576. Now let's combine those two. I got 324 plus 144, and that is 468. Those are not equal to one another, so I know for sure that is not a right triangle. Okay, so that seems pretty simple, right? I like these little examples they gave us down here, though, where they didn't even give you the triangle, but here's what they said. Tell whether the triangle is, with the given side lengths, could be a right triangle. Now, you have to use your, you got to use your brain for a second. If they gave you these 3 side lengths of a triangle, which one would obviously be the hypotenuse? The 28 inches, because it's bigger, right? So technically this would be an A and that could be a B, so this could be 21 squared plus 20 squared equals 28 squared. And does it work? Well, let's find out. 21 squared is 441. 20 squared, so 2 times 2 is 4. Add the 2 zeros we were playing with. And then 28 squared is 784. So 441 plus 400 equals 841. That is not equal. So is this a right triangle? No. So do you see how in the beginning of this chapter, they're just telling you different ways you can use the Pythagorean theorem to prove if things are right triangles? I don't think this is like a huge concept we have to really work on, because I think it's pretty obvious how to do it. It's going to be the next thing that comes up that's going to be important to me. So let's go ahead and finish this off. Which of these would be the hypotenuse? The longer side, right? So 1.25 is longer than 1. 1.25 is also longer than 0.75. So that's going to be my hypotenuse. So I'll say 1 squared plus 0.75 squared should equal 1.25 squared if it's a right triangle. Well, let's find out. 1 squared is 1. 0.75 squared is 0.5625. 1.25 squared is 1.5625. Okay, obviously 1 plus 1.5625 is 1.5625, and it equals 1.5625. Okay, great. That's awesome. Ka-chink, it works. Is this a right triangle? Yes. Okay, so once again, no notes on that, just because I feel like that's a concept that you guys should understand about the Pythagorean theorems that you can prove then if things are right angles, right? Pretty simple, nothing new. Now let's talk about this. This is the guy that's pretty important to us. This is called the distance formula. It says on page 319, you use the Pythagorean theorem to develop something called the distance formula. You can use this distance formula to find the distance between any 2 points on a coordinate plane. Okay, once again, our coordinate planes are coming back from all the other chapters. In our notes, let's go ahead and write down what the distance formula is in our first box, okay? This is going to be very important. Distance formula. And then we're going to do a little colon, and we're going to put our distance formula over there. So let's remember, this formula helps us find the distance between any 2 points on a coordinate plane, okay? And here is the distance formula. You guys are going to love this. It's chaotic. The distance, which is d, between any 2 points, x, y, so those would just be a coordinate, and x, y, 2 would be another coordinate, is given by this formula. All right, so that's what we're going to write in this little spot. D, which is your distance, equals the square root. And look how long my square root is. It is huge because everything's got to fit inside of it. x2 minus x1 and then they're saying, then after you do that, you square it. And then you're going to add y2 minus y1 squared. Oh my goodness. I know that looks crazy, but it's very similar to like finding slope in a way. When you find slope, you're finding the change in y's over the change in x. This is kind of like that. Distance equals the square root of change in y squared plus the change in x squared plus the change in y squared. We'll do some examples, don't worry. So, this is a nice little graphic to show you kind of like what they're talking about. If this was my first coordinate, right here, that dot, and this is my second coordinate, right here. If I wanted to find the distance between those two, it's basically like finding the hypotenuse. I could say, okay, here's the leg, and then here's the leg, and then if I square both of those, then I could find my hypotenuse, and that's pretty much what this formula is doing. It's saying, here's a leg, here's a leg. I know that the Pythagorean theorem says take the legs squared, and then you would get your hypotenuse. I'm square rooting it so that I don't have to then square it to my d. So I know it's weird, but let's do an example together. Let's do this one. Find the distance between 1, 5 and negative 4, negative 2. So I'm going to go ahead and copy and paste that. You can write it down, but remember, you can pause the video if I'm going too fast. I'm just going fast so that you guys can do this all in one class period. Okay, so I'm going to pop that in to this first example. Find the distance between 1, 5 and negative 4, negative 2. We're going to use the distance formula. D equals the square root change in x's squared plus change in y's squared. Doesn't matter who is x2 and who's x1 and who's y2 and who's y1. Just like slope, it doesn't matter who's who as long as you go in the same direction. So if I'm going to say that this is going to be x2, then that means this has to be y2. You have to go the same way. You can't mix and match them, okay? So the first thing we're going to do is write d equals the square root, and the square root is one long boy. The change in x's. So I like to work left to right. So can we just pretend that this is my first x and then this right here, that's my first x and this will be my second x. So it's going to be 1 minus negative 4 squared. Great. We put in our x's. That's all we've had to do. Now let's go ahead and put in our y's. if this was x1, now, or sorry, if this was x2, now this is going to be y2, okay? So if I went this direction, now I'm going to go this direction as well. 5 minus negative 2 squared. Could I have also said, and I am going to write it over here, I don't know if you guys need to, but I think it's just good for you guys to see that it's kind of the same thing, okay? So let me erase this. My notes are getting kind of messy here for a second. Let me put that back up there. Okay, so I have this formula. Could I also, ooh, you know what I'm going to do? I'm going to copy and paste it. I'm going to do the same distance formula over here, but I'm going to prove to you that order doesn't matter as long as you keep your x's and y's the same as, as they're supposed to be. So before I said this was going to be my first x that I was subtracting from this x, I'm going to switch it up now. I'm going to take negative 4 minus 1, okay? Oops. Negative 4 minus 1. Now, if I took it from that direction, now I'm going to take it from that direction as well. Negative 2 minus 5. So you don't have to do it both ways. I'm just proving to you in this first example that it works both ways. It doesn't matter who's x1, who's y1, as long as you go the right direction, right? Okay, let's focus on this guy first. What is 1 minus negative 4? That turns into 5, because that makes a plus, right? 1 plus 4 is 5. It'd be 5 squared. 5 minus negative 2. That turns into a plus as well, so it's just going to be 5 plus 2, which is 7 squared. All of that is square rooted. So now I've got 5 squared, which is now 25. 7 squared, which is 49. Take 25 plus 49. You get 74. So I've got distance equals the square root of those two numbers together, which is now 74. And the square root of 74 is nothing pretty. Let me go back to the book and make sure. Yeah, look what, this is so interesting. So this is the example that we're putting in our notes right now. They chose to go the other direction, but do you see how they still ended up with the square root of 74? And you know what's fascinating to me? The square root of 74 is something not pretty. It's 8.602325267. It doesn't end, okay? But look what they did. They just left it as the square root of 74. It's cool to know that if you get something ugly like this that doesn't equal something cute and pretty, like a nice number, you can leave it as the square root of 74. And that's what I'm going to do right there. I'm just going to leave it as the distance is the square root of 74. Let's go do our other guy over here just to make sure everything works. Negative 4 minus 1. Signs are the same, so we just add. 4 plus 1 is 5, but they're both negative, so it'll be negative 5 squared. Same thing over here. We're adding because they have the same sign. 5, 6, 7, so that's negative 7 squared. Now, why does this work? Well, obviously, because what is negative 5 times negative 5? That's positive 25. And this would be positive 49. And we just found out that 25 and 49 together are 74. Distance equals the square root of 74. So it doesn't matter which way you go. As long as you take your x's and y's from the same direction, then I don't care who's second and who's first. Okay? Let's do another one. Let's do this guy right here. Find the distance between the 2 points. I'm just going to go ahead and grab those 2 points, copy and paste them into this next example. Okay, so we're finding distance between these 2 points. I'm not going to do 2 separate equations this time. Let's do it once. So our equation is distance equals the square root of the change in x's squared plus the change in y's squared. So I'm just going to go and fill that in right here. Distance equals the square root, nice and long, change in x's. So if I start here, I'm going to say 7 minus the 9. Don't forget to square it because it's a leg, plus the change in the y's. So if I started over here, then I'm starting over here again. Negative 3 minus 6, and don't forget to square it. Okay. So far, so good. Now we just do the math. What is 7 minus 9? 7 minus 9 is negative 7, 8, 9, 2. Negative 2 squared. Negative 3 minus 6, signs are the same. So we add. This would be negative 9 squared. Negative 2 squared is like negative 2 times negative 2. Two negatives make a positive. That would turn this into 4. Negative 9 times negative 9, that would just be positive 81. Okay, so the distance is going to equal the square root, don't forget about him, of 4 plus 81, which turns into 85. And now, does that equal something pretty? No, there's nothing times anything that's going to equal 85, right? It's going to be something grossy, like 9.219544457. It's gross. So you can just leave it right there. I'm going to go and highlight my answers so that when we look back on this, we know exactly what our answers were. Okay. So the distance formula is not that bad. It's just a matter of memorizing it now. Distance equals the square root of change in x's squared plus change in y's squared. Let's do another one. Yeah, that's pretty hit. That's, pretty easy. Let's do one with a 0, 0 in it. Let's do this guy. So I'll copy and paste him. That in there. Okay, negative 6, comma, negative 7, and 0, 0. Find the distance. Let's see if you can remember it without looking up above to see what the distance formula is. Distance equals the square root of change in x's squared plus change in y's squared. Now, I like to work left to right. Let's just do that. Here's an x. Here's an x. Negative 6 minus 0. Here's a y. Here's a y. Negative 7 minus 0. There we go. We filled it out. Now all we have to do is just solve. Negative 6, take away nothing, is still negative 6. So I'm going to have this right here is negative 6 squared. Plus, same thing over here. Negative 7 minus nothing is still just negative 7 squared. Now, negative 6 squared is like taking negative 6 times negative 6, which would turn into positive 36, 49. Now, don't forget, we have that square root back there. He's still hovering over us. Distance equals the square root of 36 plus 49, which equals 85. Again? Wow. Oops, that's a knit 4. That's weird. What's the coincidence of that? That's funny. Make sure I didn't make a mistake. 4 and 81 is 85. Yeah, that works. 36 plus 49 is 85. That's hilarious. I picked 2 problems that ended up having the exact same answer. That's funny. Now, I want you to fully understand this. What this formula does, what all of these answers mean, is that if I had those 2 points on a grid, negative 6, 1, 2, 3, 4, 5, 6, negative 7, and 0, 0, it's saying, what's the distance between them? It's a diagonal line. You can't count them, right? So to find the answer to a diagonal line, you're basically just making a right triangle and finding the hypotenuse. It's just we have a formula to make it easier. All right, guys, that is it for today's lesson and notes. Now, tomorrow's video, I will be doing a bunch of practice problems with you, just like we did with 7.3, where it's just going to be like a homework assignment. Make sure you guys fill out your bell ringer today. There's going to be no exit ticket, however, after this video. All right, guys, see you tomorrow.